Today we're going to look at section 2.2, which is about slope and rate of change. Rate of change is really just another way of saying slope. This is our formula for slope. Those triangles mean a change in, so this is a change in y divided by a change in x. In our equation we can do the difference between two y values over the difference between two x values. Visually, slope is a rise over a run. So if you have a graph, you can plot 2 points and count how much did you go up over how much did you go over. When we think about running in a graph, we always want to think about heading to the right. A positive slope rises, and I say as you read a book. So when we talk about reading a graph, we read a graph from left to right. So as you move across your page from left to right, a positive slope line will be rising in value. A negative slope line will be falling. The slope of 0 is a horizontal line. An undefined slope is a vertical line. A parallel line, or a pair of parallel lines, never intersect each other, so their slopes are exactly the same. They're rising and running at the same rate. If they were rising and running at different rates, eventually they would hit each other. So parallels have exactly the same slope. Perpendicular lines, you learn in geometry, intersect at a right angle. When we're talking about slopes, their slopes are two things. They are opposite of each other. That means one should be positive and one should be negative. And they're reciprocals, which means that they're flipped over of each other. So 3/2 and 2/3. But also opposite, so one should be positive and one should be negative. So to draw examples of these slopes, that's something you should be able to be prepared to do on your test and understand that a positive slope goes upward as we move from left to right. A negative slope goes downward. A slope of 0 is a horizontal line, and a vertical line has undefined slope. You can think about it in terms of like mountains. A positive slope would be that you're climbing a mountain, you're increasing in your height. If you're going down a mountain, if you're skiing or you're done with your hike and you're going down, that would be a negative slope. A slope of 0 is walking on flat ground, and an undefined slope would be a big problem. Okay, if you were trying to walk that line, that would cause you a big problem for an undefined slope. Our first type of problem is asking us to just find the slope of the line passing through these 2 points. You have two options. You could plot your points and then count out rise over run. That's a completely valid way of doing it, but it's going to be a more lengthy process, and you're going to have to do this a lot in your homework, so it's going to be more tedious as well. But it is totally and completely valid, and some of your homework problems will actually give you a graph and ask you to find the slope. So we're going to look at what these would look like graphically. So I've got -3, 5 and 2, 1. And so to find the slope between these 2 points, what I want to do is say, how much did I rise? And always go from the left to the right. So in this case, to get from my left point to my right point, I didn't really rise. I fell. So I'm going to say that I went down 1, 2, 3, 4. -4 rise. And then how did I run over? 1, 2, 3, 4, 5 spaces. So my slope is rise over run, -4 over 5. The numerical way of finding a slope is a change in a y over a change in an x. So these points give us x and y values. So what we want to do is subtract the y's and divide by subtract the x's. It doesn't matter which way you do it, you should get the same answer as long as you're consistent. So if I go 5 minus 1, then I need to go -3 minus 2. So go in the same order for the x's as you did for the y's, and you should be in good shape. So I get 4 over negative 5, which is exactly what we got graphically. Or if I went the other way and went 1 minus 5, I would go 2 minus negative 3, and I get negative 4 over, being careful of double negatives, 5. So we can see that we've got kind of 3 different ways we did the problem. We got the same answer, all of them. We graphed and did rise over run. We subtracted in one direction, we subtracted in the other direction, and we kept getting the same answer. So in this problem, to find the slope, again, we could plot the points. So negative 2, negative 4, and 3, negative 1. And then I can think about rise over run. If I go up and over to the point, I went up 3 spaces and over 5 spaces. So rise over run would be 3 over 5. Or I can do a subtraction, negative 4 minus negative 1 over negative 2 minus 3. Careful of double negatives, gives negative 3 over negative 5. Cancel the double negatives, gives 3 over 5. You should get exactly the same answer if you subtract in the other direction as well. Just make sure whatever direction you subtract the y's, you do the x's in the exact same order, so that if we look at our problem, if we look at our fraction, we should have points stacked on top of each other that way. This problem specifically says without graphing them, tell whether the line rises, falls, is horizontal or vertical. So what I'm going to do is find the slope between them. So I'm going to subtract y minus y over x minus x. Double negative makes me add on the top and get 2. On the bottom I get 2. So I have a slope of 1. So to tell whether this rises, falls, is horizontal or vertical, remember rises means that we have a positive slope, falls is a negative slope, horizontal is a 0 slope, and vertical is an undefined slope. So we ended up with an answer of positive 1, so that means that this line rises. Same directions here. I want to tell whether it rises, falls, is horizontal or vertical. So we're going to subtract y minus y over x minus x. Subtract on the top and I get negative 6. On the bottom I get 0. Dividing by 0 is like the biggest no-no in math. So 0 on the bottom of a fraction creates an undefined value. When 0 is on the bottom, that's a big problem. So this is undefined, which means we have a vertical line. 0 on the top is okay. 0 on the top is just equal to 0. So if in a problem you do your slope and you end up with like 0 over 2, that's 0, and that would be a horizontal. But if 0 is on the bottom, that's a problem. That is undefined and it creates a vertical line. Same directions again. So we're going to subtract y minus y over x minus x. On the top I get negative 2. On the bottom I get negative 3. Double negatives cancel, so I end up with a positive 2/3. Positive rises. One more of this type. Y minus y, careful of double negatives, over x minus x. So double negatives on the top give me 0 over negative 2. So where we said 0 on the top is an okay thing. 0 on the top means 0, and 0 means horizontal. Here we're asked to tell which line is steeper. A steeper slope will be a larger absolute value. So if I have a positive answer and a negative answer, I don't really care about positive and negative. I don't care whether the line is rising or falling, but which number has the bigger value. So what we need to do is find the slope for each line and compare them. So for line 1, I'm going to do y minus y over x minus x gives negative 4 over negative 2, which gives 2. For line 2, I'm going to do y minus y over x minus x, and I get negative 3 over negative 5, or 3/5. Then we want to compare which one of these is bigger. The bigger slope is the steeper line. So the winner here is 2. So line 1 is our steeper line. Another of that same type. So for line 1, y minus y over x minus x, and I get negative 6 over negative 4. Double negatives make positives, reduce gives 3/2 or 1/2. When we talk about slopes, we tend to leave them as fractions though, instead of turning this into 1.5 or 1.5, because if we leave it as a fraction, that shows us a rise over a run. For the second line, do negative 5 minus negative 2, negative 2 minus 1. Double negative on the top really makes me add, and I get 3 over negative 3. Sorry, on the top I get negative 3. Also negative 3 on the bottom, so that gives me a positive 1. Positive negatives don't really matter so much when we're talking about steepness. We just want to say which one's bigger. 3/2 is bigger than 1, so line 1 is the winner. For our last type of question, we want to say whether the lines are parallel, perpendicular, or neither. Parallel lines will have exactly the same slope. Perpendicular slopes will be opposite and reciprocal of each other. And then if it's not one of those, then it's neither. They intersect, but they don't intersect at a right angle. So, like the last problem, we need to find our two slopes. So line 1, I'm going to go 3 minus negative 1, negative 3 minus 3, gives 4 over negative 6, reduces down to negative 2/3. For line 2, negative 3 minus 3 over negative 2 minus 2 gives negative 6 over negative 4. Double negative cancels, reduces down to 3 over 2. So then we have to ask ourselves, are these two slopes equal? No, so they're not parallel. For perpendicular, they have to be opposite. So one has to be positive, one has to be negative, and reciprocals, so they have to be flipped over. That is the case here. 2 over 3 and 3 over 2. One of them's positive, one of them's negative. So these lines are perpendicular to each other. Same directions here. So for line 1, 1 minus 4 and negative 3 minus 3, negative 3 over negative 6 is 1/2. Double negatives cancel. Line 2, negative 3 minus 1, negative 4 minus 4 gives negative 4 over negative 8. Double negatives cancel, reduces to 1/2. So for both line 1 and line 2, we got an answer of 1/2. That means these lines are parallel. They're rising and running at the same rate, so they're never going to run into each other. Last example, for line 1, negative 2 minus 1, And negative 2 minus 4 gives negative 3 over negative 6, or positive 1/2. For line 2, negative 3 minus 5 over negative 3 minus 1 gives negative 8 over negative 4. Double negatives cancel, gives positive 2. So, parallel, perpendicular, or neither. They are not exactly the same, so the lines are not parallel. For perpendicular, 1/2 and 2 are reciprocals of each other, but they are not opposites. Since they are both positives, that's not good enough for perpendicular. For perpendicular, we need one positive answer and one negative answer. So, these two lines are neither. They intersect, but they do not intersect at a right angle. One more question about this type of problem. I want you to think about for a second the slopes 0 over 4 and 5 over 0. So if we would solve this kind of problem, and these would be the two slopes that we would come up with for line 1 and line 2, are these going to be parallel, perpendicular, or neither? Well, what we have to do is think about, what do these really mean? If I have a slope of 0 over 4, that really means 0. And what kind of a line has a slope of 0? The slope of 0 is a line without slope. It's not rising or falling. It's just a horizontal line. So in our hiking example, that's just flat ground. But where we divide by 0, that's our no-no, so that creates an undefined slope. And in our hiking example, that was the line that would cause us some problem if we were trying to hike it. That's a vertical line. So these two are actually perpendicular to each other. This was our symbol for perpendicular that we learned in geometry, or you can just write perpendicular, or you can abbreviate it. But a horizontal and a vertical line are perpendicular. So even though our two starting ones were not actually opposite reciprocals of each other, because these are a special case of horizontal and vertical lines, they did in fact end up being perpendicular. Your homework for tonight is from section 2.2. And like our assignment here, our lesson, you're going to be doing a whole lot of slopes. So just remember y minus y over x minus x. And make sure whatever order you do the y's, that you do your x's in the same order.